Thank you for the invite to talk to the audience today on the subject of bioplastics in this Future of Food Packaging seminar. For anybody who doesn't already know me, my name is Brona Miller and I have worked in the Polymer Processing Research Centre at Queen's University for almost 20 years now. I manage the characterisation and testing facilities in the centre, looking at polymer materials and products. So some of you might know me through some of our industrial troubleshooting work or the training courses that we run in the centre, or maybe some of the extrusion and moulding work that has carried on in the centre. I've always been interested in sustainable materials, but in the past 4 or 5 years, I've really gotten interested in bioplastics, and they're a real area where they have recently grown from being a very niche material into a more widely known material that have really grabbed consumers' attention. The question I really want to focus in today for ourselves on is whether or not these materials can meet consumer demand for more sustainable packaging for the future. So when the consumer thinks of traditional fossil fuel polymers and their role in packaging, I think it's fair to say that there are a lot of very negative connotations that come along with those. People will think of a dirty pollutant oil industry that produces these materials, marine littering, they'll think of litter on our beaches and on our streets. And unfortunately, that's the imagery that you get conjured up with fossil fuel polymers. Not perhaps fair, but that's the image that a lot of consumers think of when they think of them. On the flip side, the imagery that we get for bioplastics is quite different. The imagery that we get for bioplastics is certainly very green, very environmentally friendly, associated with sustainable activities, that they're non-polluting, that they're one with nature, environmentally friendly. And actually the images that we've got now on the screen, they're from promotional literature from bioplastic providers. So it's certainly the imagery that we're being taught to expect around the area of biopolymers. But is it really that simple? There's really an awful lot of confusion around this whole topic of bioplastics for the consumer and actually for us, the packaging professionals as well. So I think it's worthwhile that we have a moment to think about what these terms actually mean and what a bioplastics actually is. So a bioplastic is a plastic material which is either bio-based or it's biodegradable, and it can be both. What we mean by something that is bio-based is that it is grown from, the materials that are used are grown from biomass. Now, that's materials like corn or sugarcane. It doesn't actually mean that the whole polymer itself comes from biomass. It's only about up to a minimum of 30% content has to be bio-based for that polymer to be labelled as a bio-based polymer. The other term that we should be familiar with is the term biodegradable. And what that means is that the plastic material will biodegrade by the action of microorganisms on it and turn itself back into biomass, water and CO2. We have bioplastics that are bio-based. We have bioplastics that are biodegradable. Not all bioplastics are all of these things. And it's a very common misconception that if the material is bio, it means it's bio-based and biodegradable. But actually, only about 40%, 43% of biopolymers are bio-based and biodegradable, which is what the consumer really thinks they all are. So that's a very common misconception. So I think it's important that we understand what these terms actually mean if we're going to talk about bioplastics and the role they're going to have in sustainable packaging. So I want to take a look at the two main families of materials that we have in the bioplastics. And the first one are the materials that I like to call durable drop-ins. So durable drop-ins are very interesting materials. They're manufactured in exactly the same way as fossil fuel plastics are manufactured. So they're made by the same manufacturers, they're made using the same processes. And what we do with those is we actually drop in ingredients that have been produced from biomass to produce these materials. So we have biopolyethylene, bio-PET, biopolyamides, and biopolypropylene. And the beauty of these drop-in materials is that when you buy a batch of bio-PE or a batch of bio-PET, you don't require any changes at all in your processing setup, no changes in the technology. So they process like for like with existing fossil fuel plastics. Now, these materials are completely compatible with existing recycling streams. So a bio-PE or a bio-PET can be recycled alongside ordinary PEs and ordinary PETs. They're 100% recyclable, 100% as durable as those other materials are. But the key thing is they are not biodegradable. So that's why we call them durable drop-in plastics. So they're interesting materials because they will reduce our reliance on fossil fuels, which is a great thing. And up on the screen, you can see a couple of nice examples of where they're being used. So Lego, about 2 or 3 years ago, introduced their botanicals range of little plastic articles, and obviously they're trees and they're garden type parts, and they're made out of biopolyethylene, which is a really nice nod to environmental sustainability. And a lot of people will know that Coca-Cola a number of years ago introduced their plant bottle, which is about 30% recycled, which is made up of about 30% bio PET, and the other PET in it is the usual fossil fuel PET. So by using these drop-in bioplastics, we can reduce reliance on fossil fuels and create better sustainability that way. So we might think that's the problem solved. Is it the problem solved? Well, actually, we don't produce enough of these materials. So these drop-in bioplastics, they are produced annually, about just under 1 million tonnes annually are produced of these drop-in bioplastics. And if we look at the entire global consumption of packaging overall, and this includes all packaging materials, not just food packaging, it's about 140 million tonnes per annum are consumed of that packaging. So at the minute, these drop-in bioplastics could only replace under 1% of that current packaging demand. So there would need to be a really, really large upskill in production to make an impact on that side of the plastics problem. Can we scale up that production? Well, when we look at the available global agricultural area that's currently used for manufacturing bioplastics, it's actually under 1% of the global agricultural area is used for manufacturing bioplastics. 0.015% is currently used, and it'll probably increase up to 0.02% in a few years' time. So that's a tiny, tiny slice of the pie. It's even smaller than the amount that's used for biofuels. So if we were to try and scale up production of bioplastics to, say, meet 50% of the demand for packaging in the world, we would still need about 1% of that actual area to do that, which is about equal to the volume that's used for biofuels. So in reality, that's a very, very small slice of that agricultural picture, but we need to consider, is it ethical to do that? So is there competition for the land if production is increased, if we try to, say, reach 50% capacity for replacing all packaging material? And should we do that if there's food poverty and land poverty in the world? Well, the good news is that all the research suggests that there wouldn't be any reason for displacing land use if we did up our bioplastic production. In fact, about 1/3 of the world's global food production is actually lost or wasted currently. And that wasted material could be used and could be diverted to be the feedstock for bioplastics. So in reality, if we upped production of bioplastics, we could help stabilise food prices and actually create jobs around that area. So it's really positive that we could increase production of bioplastics without affecting things like land poverty and food poverty. So sounds good, but there is a sting in the tail, like there's a sting in most tails. Are these materials more expensive? And at the minute, they are more expensive than those fossil fuel polymers. So to go for a more sustainable option is going to cost people more. And at the minute, biopolyethylene is about 50% more expensive than fossil fueled polyethylene. So unfortunately, there is a payoff for a more sustainable alternative. But with changes in the future with the ways in which material are manufactured and bigger buy-in into materials like that, that price differential will drop down also. So in reflecting on whether drop-in bioplastics are a solution to meeting that consumer demand for sustainable plastics, for sustainable packaging, I do think that there is really good potential for this family of bioplastics. They do process like for like with current fossil fuel plastics, which is a great thing for manufacturers. We can simply slot in that bioplastic into existing manufacturing without any issues or any problems. They are completely recyclable and they don't disrupt our current recycling infrastructure. That means that for our recycling MRF plants that we have here on the island, they will not have any problems with recycling a bio-PE, biopolyethylene versus a fossil fuel polyethylene. They won't see any differences. There's nothing to make it stand out from the normal polyethylene, PET, PP material. So they're totally recyclable and totally non-destructive to that infrastructure, which is great. They are sustainably sourced compared to fossil fuels, so we do improve sustainability by using them. If we continue to use them and if we use them in a greater quantity than we are using at the moment, they will not be displacing any land use for food production. So there are no ethical concerns over using them with world food property or world land property. And actually, we could be utilising agri-food waste that is wasted and spoiled in food production already. So we could be using non-edible materials in entirety to make these materials. Of course, they are more expensive at the moment, but that cost should fall as the technology matures. And I think that's the thing with all materials that are new onto the market. They will be more expensive in the short term, but in the long term, we should see drops in those costs. The confusing thing for the consumer, and this comes up time and time again, is these plastics are durable plastics. They are not biodegradable or compostable. And if people label up packaging to say they are biopolymers, bioplastics, grown from corn, market information like that, there is an awful lot of confusion with the consumer, and quite often the consumer thinks that's biodegradable, that's compostable, I should put that in my compost heap, or I should put that into my compost bin. So we have to be very careful with the messaging around these materials. These are simply materials that improve the sustainability of the existing plastic infrastructure and don't create an entirely new plastic material that has to be developed and disposed of in an entirely new way. The other type of bioplastic material are the materials that we call the compostables. So that's a different family of bioplastic materials altogether. These bio-based compostable materials are manufactured from biomass also. So they're also manufactured from sugar, corn, those sorts of materials. And typically they would be materials like PLA, polylactic acid, PBS, polybutylsuccinate, and another one there, PHA, polyhydroxyalkanoate, which is actually can be grown from methane waste that comes from sewage and landfill. It's a very interesting material in itself. These materials are manufactured from biomass and they are biodegradable and therefore compostable. And they are already used in food containers, they're already used in packaging. Anybody who has a food caddy bin that you send off your food waste in, wrapped in a liner, a compostable liner film, will have touched and used these materials because they're used in the manufacture of those. And they find great use in single-use items as well. One thing to note with these materials is they're often blended with other fossil fuel polymers to try and tailor their performance, because on their own, these materials don't really stand up to the properties that we're accustomed to in our packaging materials. So they wouldn't have the same strengths, the same stabilities, and they wouldn't necessarily have the same barrier properties as a food packaging material. So often they are blended with other fossil fuel polymers to tailor performance. Now, those could be fossil fuel polymers that are compostable as well, so we're not affecting their compostability, but they're not usually used on their own. They're usually multi-materials blended together. These compostable materials are 100% renewably resourced as well, and they are biodegradable, so they do reduce our reliance on fossil fuels. So that's a great tick for sustainability too. However, they are produced in a much smaller volume than our drop-in bioplastics. So these are much more niche materials, and you wouldn't come across them as often as you would those drop-in durable bioplastics. I think it's very important that we look at the composting process, because this is the whole point of producing a compostable polymer, is that it is composted at its end of life. Compostable bioplastics on the whole are designed to biodegrade in industrial composting facilities. Now these are facilities that run at elevated temperatures, say 50 to 70 degrees C, and they have controlled humidity in order to produce the CO2 the water and the compost type materials from the polymers and other materials that are being composted. This whole process can take many, many weeks to complete for a bioplastic material that's compostable, so it is an industrial scale process. The temperature and humidity that you would have in a home composting kit is generally too low to properly degrade bioplastics. It's great for food waste and foodstuffs, but it really struggles with bioplastics, and they could actually take years to decompose in a home composting facility. And and packaging that is contaminated with meats and fish, home composting really struggles to deal with those. So the route for these materials that are manufactured to be compostable really is to be industrially composted at the end of their life. Any compostable polymers that you see that are being promoted to be used in packaging applications really should be certified with the seedling, which you can see there on the screen, or the OK Compost Tough Austria type certification to say that they are fit for purpose for these industrial type composting facilities. And if you do come across packaging that's labelled as compostable, which I do quite a bit, and it hasn't got these certification stamps on it, you should really question as to whether or not there is any evidence to prove that they do compost in those facilities. So currently we have a bit of an issue with what we should do with our compostable plastic packaging. The consumer is most certainly confused as to what to do with it, as am I quite often, and as are many of us. So what should we do with those materials at the end of their life, whilst we don't really have that compostable infrastructure for collecting these plastics properly available at the moment? Should they go in your food waste bin? Well, no, they shouldn't go in the food waste bin, because sorting technology isn't going to be available in composting facilities to remove that plastic. It's seen as a contaminant and it would be removed, or it would spoil a batch of compost. So please don't put them in your food waste bin. Should they go into your recycling bin? Well, no, they shouldn't be going into your recycling bin either, because equally the technology is not available to discard those compostable plastics easily from the recycling process, and they have a tendency to get in there and contaminate the plastic material that is being recycled from your recycling bin. And remember, that's an extremely valuable material that has got an extremely long life associated with it, and if we get compostable materials in there and contaminate that, we spoil that material and reduce the value in it. Now, I've put red X's through those because that's a definite no-no. Don't put it in your food waste bin and don't put it in your recycling bin. I haven't quite put a tick against the rubbish bin, and the reason for that is this is where they should go in the meantime. They should be going into the rubbish bin, and that's the place for compostable plastics at the minute. But that means they land and they end up in landfill, which unfortunately is an environment where they won't compost in the way they've been designed to. They will go on to produce greenhouse gases in that environment, which is bad for our environment, and that's because there's a lack of oxygen in landfill for them to compost naturally and compost fully. So by putting them in the landfill rubbish bin, that's what we need to do at the minute, but that's not what we should be doing long term with them. That's not what they're designed to do. So I've resisted the urge to put a green tick beside that, because it's where they should go, but it's not where I'd like them to go. So these compostable materials are great materials. They're fantastic materials for our future. I really do believe that they have a great use for us. Do they meet the current demand for the consumers' demand for sustainable packaging? I think what we should really think about is the fact that not all compostable materials are necessarily biosourced. They don't all come from biomass. Some of them come from fossil fuels as well. So they're not a complete replacement for getting rid of fossil fuels for packaging, but they can improve sustainability if they are the biomass sourced variety, and then they are composted. Like our drop-in plastics, about 1% of them is currently available to meet our current packaging needs. So there would need to be a huge increase in production in order to meet a larger percentage of our packaging needs. But the problem is with these materials is they don't necessarily process like for like as our current fossil fuel packaging materials will do. So industry readiness is an issue. There needs to be maybe additional drying or gentler processing of materials for, say, somebody who wants to produce plastic film for them. So the industry readiness is an issue. They are extremely disruptive to our current recycling infrastructure because they do not recycle well alongside our durable plastics. We do not want to put them into our recycling stream. We want to keep them from our recycling stream. They are designed to be composted, and at the moment, no, they are not being collected to be composted. So that infrastructure would need a lot of investment and a lot of work done on it to make our current infrastructure ready to be able to deal with these plastics, which is what they should be aimed towards. That's what we should really be doing with these materials in the long term, designing for them to end up in a composting stream. So I think they're part of our future solution. The drop-in bioplastics that we looked at initially, I think, are more of the initial solution, but these are part of our future solution. But it's still an immature technology. It's a very niche technology. It's very low percentages of these materials are made compared to what we actually need. And that whole composting infrastructure needs a great deal of work around it to fully make this a circular economy and to make the growth, use and disposal of these materials fully circular. So there's a lot of work to be done with compostables. So really, in conclusion, how do we meet consumer demand for sustainable packaging? Well, there's a lot of things we can do with our existing packaging, which I'm not focusing on in this talk. There's a lot we can do to improve our recyclability. There's an awful lot we can do to improve the design of packaging materials from the outset, so that they are recyclable, that they are revalorizable in the recycling stream. But with respect to bioplastics, I do believe that we can increase the amount of drop-in bioplastics that we're using to reduce reliance on our fossil fuel plastics. And that simply is an addition of that bio content without any change to anything we're doing at the moment. Compostable bioplastics are fantastic materials, but I think that they should be targeted for single-use items where they are absolutely necessary, and for heavily food contaminated packaging that we can't divert into our recycling stream at the minute. So that's where I think compostable bioplastics have their niche area, and we should continue to grow and invest in that area. And what we need to do hand in hand with that is improve our industrial composting infrastructure and collection systems. So thank you for listening to me, and that's my opinion on how we meet consumer demand for sustainable packaging for the future, and thank you for the invite.